Hello all, let's start section 3.2. Our section 3.2 is polynomial functions and their graphs. What is a polynomial function? It's written there. Any function that's in the form of f of x equals a sub n to the power of x n, correct? For example, if I put a numeric example here for you, f of x equals 3x to the power of 4. Your 3 is a sub n, and x to the power of 4, n is equal here 4, plus a sub n minus 1, x to the power of n minus 1, which I can give you, for example, 2x squared, the next term, minus 4x, plus 5, correct? These type of functions, we call them polynomial functions. Or, if I explain it in a better language, simple language, any function that you don't see a variable under the radical, your variable is not under the radical, or the power of your variable is not a rational number, it means a fraction, those type of functions, we call them polynomial functions. But if you see these two in a function, you cannot call them polynomial. For example, f of x equals 2 radical x minus 4 x squared plus 3. I cannot call this one a polynomial function. Why? Because here, my variable is under the radical. Or f of x equals 3x to the power of 1/2 plus 2. 2x to the power of 1/3. This is not a polynomial function because the power of your variable is what? A fraction or a rational number. Now, let me erase these examples back and this time explain something else for you. Now, in this general form that I put for you, f of x equals a sub n, we call a sub n the leading coefficient. Leading coefficient. Your a sub n is the leading coefficient. What does it mean? The coefficient of the highest exponent, we call that one the leading coefficient. Numeric example, if I have, for example, f of x equal 3x to the power of 3 minus 4x plus 5, a polynomial function, immediately I have to know what is the leading coefficient. The leading coefficient here is what? 3. Because x cubed is the highest exponent in my polynomial function, correct? Or if I have f of x equals 2x plus 4x squared minus 5x to the power of 5, where is the leading coefficient? You have to be careful not to. What is the highest exponent? The highest exponent is x to the power of 5. Then what is the leading coefficient? A sub n is here negative 5. Your leading coefficient is negative 5. Correct? That's the important part that I want to explain to you. N is the degree of your polynomial function. For example, in this example, in number 1, f of x equals 3x cubed, this is a cube function or third degree function. In the next one, which is I have f of x equal to x, 4x squared minus 5x to the power of 5, this polynomial function is at degree 5. Correct? Because n is equal what? N is equal 5. Now, let's talk about some characteristics of a polynomial function. How? By looking to a graph, for example, how you should know if this graph is belong to a polynomial function or not. Number one, the graph of a polynomial function is always a smooth curve. What does it mean, a smooth curve? It means when you put your pencil on a paper, you never pick it up and you draw really a smooth curve. Smooth curve means your curve doesn't have any corner. Like this. For example, if I draw another one, this is the graph of a polynomial function. It's a smooth curve. But this one, if I have a corner in it, for example, this is not the graph of a polynomial function. Why? Because here I have a corner. The graph of a polynomial function doesn't have a corner. It's a smooth curve. Any shape of curve, but the curve is smooth. Also, if you see a gap means your graph has two parts. Like this, maybe. This one will be a good example of having a gap. This is one function. It's not two functions. It's one function, maybe a piecewise defined function. This graph has two parts in it. There is a gap. This is a gap from here to here. There is a gap there, correct? This is not representing a polynomial function. It means the graph of a polynomial function doesn't have also a gap, correct? No corner, no gap. These are the characteristics of a graph of a polynomial function. Now, a very important topic that we want to discuss now is end behavior of polynomial functions. And behavior of graph of polynomial functions. Correct? In your book, they just simplified this name and behavior of polynomial functions. It means the graph of polynomial functions. The graph of a polynomial function has an end behavior. What does it mean, end behavior? I will put few examples here for you. If I draw, for example, a function like this, a graph like this, or if I graph a function like this, like W shape, my name, Walid, correct? You can see clearly that the graph of a polynomial function has an end behavior. What is the end behavior? What the graph does on the far left side and what the graph does on the far right side. Here, left side of the graph, right side of the graph. We call those the end behavior of a graph. Now, the end behavior of a graph of a polynomial function is directly belong to a leading coefficient and the degree of the polynomial function. How? I'll explain here in 4 separate cases for you. Correct? Case number 1. If the leading coefficient of a polynomial function is greater than 0, it means your leading coefficient is a positive number and the degree of your polynomial function is odd. N is what? Your n is odd, an odd number. Correct? What is the end behavior of the graph? The graph always falls on the left side and rises on the right side. The shape of the graph will be always like this. You see, the graph falls on the left, rise on the right side. This is the end behavior of the graph. How I should know if there is no graph? Based on the given function. For example, they gave you f of x equals 3x to the power of 5 plus 4x squared minus 3x plus 1. What is the end behavior of this graph? How much is the coefficient? A of n is equal 3. The leading coefficient is 3 and 3 is greater than 0. It means it's a positive number. What is the degree of your polynomial function? The degree of your polynomial function is 5 and 5 is an odd number. Then immediately if someone is asking you what is the end behavior of this function, even they are not giving you the graph, you should write this. The graph falls on the left side and the graph rises on the right side. That's it. Write it in English or just draw these 2 arrows. Every math professor, they know what you are talking about. When you are talking about end behavior, if you just draw these 2 arrows, it means the graph falls on the left side and rises on the right side. This is your case 1. Correct? Case 2. If the degree if the leading coefficient, which is a sub n, is less than 0, it means you have a negative leading coefficient. And still, n is odd, an odd number. In this case, what will be the end behavior of your graph? Let me show it in a graph for you. The graph of the polynomial function, rises on the left side and falls on the right side like this. Left up, right down. This one will be the end behavior of your graph. Numeric example, but based on the function. For example, a very simple one, f of x equals negative 3x cubed. Or let's say put another number if you want to see it like this, negative x cubed plus 2. What is a sub n? What is the leading coefficient? Negative 3. And negative 3 is less than 0, right? It's a negative number. What is the degree? the degree is 3 and 3 is an odd number, then what is the end behavior of the graph? The graph rises on the left side and falls on the right side. Correct? You see, like, mathematics is really beautiful. If you know these stuff and you want to graph a polynomial function, by looking to the graph, to the function, you know what will be, you can guess what will be the shape of your graph. Oh, the left side will go up, the right side of my graph will go down. There is a zero chance of doing mistake when you are graphing if you know these topics perfectly, right? Case number 3. If a of n is greater than 0 again, it means a of n is a positive number, and this time n is an even number. What will be the end behavior of the graph? The end behavior of the graph is like this. I don't care what's happening in the middle, right? How many times I'm going up and down. It's based on the polynomial function. I'm talking about end behavior, right? The end behavior of the graph is the graph rises on the left side and the graph rises also on the right side. Both sides is going up, left and right. Correct? Now, if they give me a function like this, f of x equals x to the power of 4 plus 3x squared minus 4x plus 1, and they ask you what is the end behavior of this graph, even you don't have the graph. By looking to the function, I know that a of n is equal 1. Your leading coefficient is 1, correct? Which is the coefficient of x to the power of 4. And 1 is greater than 0. It's a positive number. The degree of your polynomial function is 4, which is an even number. Then the end behavior is the graph goes up on the left side and the graph goes up on the right side. Case number 4. A sub n, the leading coefficient, is less than 0. It means it's a negative number. And n is, again, an even number. What will be the end behavior of the graph? X, y, a very simple graph, a parabola. Both sides of the graph goes down. The left side falls down, the right side falls. Correct? That's the end behavior. Down, down. Or some people draw it this way. Down, down. Numeric example, or with a function, f of x equals x squared plus 2x plus 1. Again, a sub n, sorry, negative x squared. A sub n equals negative 1. The leading coefficient is negative 1. N is 2, which is an even number. Then the graph falls on the left side and falls on the right side. These are the 4 cases that you can see when you are graphing a polynomial function, and we call it the end behavior of a polynomial function. Now, Even my table is not, I don't like it. Let me draw a table here. If I write all these four cases, if I show it in a table for you to can memorize easily, if I draw a table like this for you, I can put all the cases here for you. Here, n is odd. Here, n is even. Correct? Here, an greater than 0. Here, a sub n less than 0. If a sub n was greater than 0 and n was odd, that was the end behavior of the graph. Left down, right up. Here, both of them up. A sub n less than 0, left up, right down. Here, both down, left down, right down. That's four cases. That's all four cases in one table. And this table is on page 367 of your book. On page 366, bottom of the page, there is the explanation of four cases, and also in the PowerPoint slides that I uploaded for you, it's explained very well there. Correct? Now, there are examples which we already did four of them, that they are talking using the leading coefficient test. We call this one leading coefficient test. Correct? Leading coefficient test means look for the end behavior of the graph. Let's do one more example from your book. Example number 1. Use the leading coefficient test to determine the end behavior of the graph of f of x equals x cubed plus 3x squared minus x minus 3. Use the leading coefficient test. It means look for the a of n and look for the n. How much is a of n or a sub n, the leading coefficient? The leading coefficient, here you see the coefficient of the highest exponent, which is 1. And immediately you know 1 is a positive number. It's greater than 0. Correct? How much is the exponent, the leading exponent, or the highest exponent, or the degree of your polynomial function? The degree of your polynomial function is 3. Now, you have the table. Correct? This polynomial function is, and 3 is an odd number. It's an odd number. The leading coefficient is positive. Then what is the end behavior? Left goes down, right goes up. That's the answer for this problem. This easy. Usually, if you want to write it down in the test, this one will be a very good way of writing. Parentheses, arrow down, comma, arrow up. That shows the end behavior of the graph. I want to do this lecture in short videos for you, not all of them in one video. That's why I'll stop the lecture here and I'll put another topic, which is zeros of polynomial function, in a separate video for you, because each video I want you to focus and see on one topic, correct? Because 3.2 is really a long section. It's like 5-6 pages section. I don't want to do a long lecture. That's why I'll stop it right now. In next video I'll cover the next part of our lecture, which is zeros of a polynomial function.